Hello friends, welcome to the next session. So in this session we would primarily talk about the entire machine learning life cycle, right, where we would talk about the entire process. So when suppose I decide that I would be applying a machine learning to my problem, so what are the phases in which I need to go, right. So the first step in this life cycle is the definition of the problem definition. So I should be very clear that whether the machine learning is the right approach for me. So that clarity is required in my head, right. I need to understand what you are trying to predict or classify and whether this is required or not, whether the machine learning approach is required or not. So actually before collecting the data, no, before choosing the algorithms, which algorithm you would like to go upon, we must have 100% of clarity on the problem that we want to solve, right. Then the stage actually defines with number of pointers that you can talk about, like what is the goal of the prediction. For example, might be suppose I want to predict diabetes or whether person has diabetes or not, right. We can ask another question like what type of output we need, whether it is in terms of yes or no, right, whether a price is to be predicted or what, right. Similarly, what input features or the data is available to us, right, health metrics, house features, emails, depending on the problem that we have. Now, who will be using this model, that clarity should also be there, like doctors, customers, whether it can be embedded into some software, right. Then what benefit does this model would bring about, right. So, better diagnosis, it can help us in filtering out the mails as a spam or not spam, right. So, that clarity, so raising these questions actually can help us in understanding whether machine learning would be the right approach or not. Now, the most important the second stage would be the data collection, that is where you getting the right data. It is not only about collection of the data, more or less it is about collecting the right data. So, I told you this is the most important step, because good data means good model, right. Good data means good model. So, where can data come from becomes the utmost priority. So, the data might be coming from databases, like for example, hospital patient database needs to be collected from the hospitals, right. It can be from websites, right, your real estate website for house prediction, for example. It can be the census data, for example, like you that might be collected by fitting a lot of sensors for the required purpose, right. It can be coming from the surveys, customer feedback for product reviews, for example. It can come from public databases as well. For example, the databases Kaggle, UCI machine learning repository, the government portals and databases which are publicly available. So you need to have a very clear understanding what data is required and where this data would be available, authentic data would be available, because ultimately you are going to train your models on this data. So, if the garbage is there, if the data is not correct, you cannot expect the algorithms to be or model to be built upon it, right. So, there can be real world examples. For example, Netflix collects viewing history of the users and they just recommend you movies. So, this is what exactly it is doing, right. It is self-driving cars, they collect the road images from the cameras, right. The weather forecasting might be collecting the early temperature, humidity data, etc. So, the data collection mechanism and from where the data would be collected is important, right. Then the third aspect I would rather say is the data preparation part, which is actually one of the most important and the critical aspects of machine learning life cycle, where the first aspect in data preparation is the pre-processing of the data or the cleaning of the data, right. You have to ensure that the data is suitable. It is not that you have just collected a chunk of the data and then you cannot expect by applying that algorithm or machine learning algorithm, it would be able to solve a problem. So, you need to actually convert that data into usable data for that particular algorithm or for the machine learning algorithms. So, real world data is never clean, that is the truth. So, we must fix the problems. The fix the problems can be, there can be missing values in the data, there can be indirect entries into data, there can be inconsistent formats, right. There can be outliers or the extreme noise in the data. So, there can be number of issues, there can be duplicated records. So, you need to ensure that the data is clean, the data is not with a lot of issues in terms of consistencies or incorrectness values, right. There can be a number of examples, right. So, missing, for example, you can replace the missing age values with the in the medical literature with the average age. So, if the data has these issues which I have just talked about, you need to treat those issues, right. Either you do not take that particular data, that particular row or a data, or if you have taken that data, then you have to treat that data. It cannot be incorrect data, it cannot be with those issues, right. Then there can be feature engineering can be one of the another aspect after you clean the data, after you pre-process the data, right. So, the feature engineering and the selection, it is like preparing preparing your smart inputs actually, right. So, it is not that you have just removed those issues or inconsistencies in the data, again it is not enough. Now, you actually should talk about like what are the important features my machine learning would be built upon. For example, in particular case, there might be thousands of features, like taking all those 1000 features may be unnecessary, may not be useful. So, I have to conclude what all features would be important, because ultimately you need to develop formulate a function between the input and output. So, what are the inputs, what are the features which are important, because you cannot formulate a function on junk features, right. So, features is what information the model would actually use to learn. There can be many features which may not be useful, right. Sometimes the raw data may not be enough, right. You need to create better features. So, there can be many examples. The raw data can be a date of birth, for example, right. You may need to convert them into an age, because that is more calculatable, right. It can be email text, that can be raw data. Again, you would like to count in terms of the spam words or not, right. Again, GPS movement data, for example, you would like to convert it into something classes like walking, running or driving. It can be image data, where the pixel intensity would be more useful, right. So, there can be number of ways where the raw data needs to be converted into process data, which is more useful. There has to be the important features that need to picked up, so that I can actually ensure that the model that I am going to develop would be useful, right. Now, the next aspect in this would be the model training part, where you would be teaching the machine, right. So, when you teach the machine in this step, you need to choose a machine learning algorithm, right. You need to feed it with the process data, right, and it learns patterns in the data ultimately, right. So, model is what I told you, it is nothing but the approximation of the function. It is the formulation of that function between the input and output, right, because we does not know how to define the rules. So, when you talk about the examples in machine learning, there can be number of machine learning algorithms. I told you that machine learning algorithms, there cannot be a single algorithm, it cannot, because the data would be different, the kind of learning that would be required for different set of data would also differ, right. So, linear regression is one of the examples which can be used for predicting house prices. It can be decision trees, like which can be used for predicting whether customers will buy or not, right. Then it can be random forest. There are number of approximation, the number of algorithms which with the time you would learn. There can be random forest. So, many algorithms, there can be neural networks which are a specific purpose. So, in a real world, you train a model on, say for example, a blood sugar level, there can be age or BMI, these can be 3 particular features, and you want to predict on these particular features that they predict whether the person would be having diabetes or not. Now, in this 3 features, you cannot expect that an address would be useful or the name of the customer would be useful feature in predicting whether a person would be having diabetes or not. So, that is what I was talking about. So, having or understanding about which feature is important or not is very important, right. So, model improves the accuracy each time it learns from more examples, that we have talked about before also, that the moment you give more and more examples, you are giving more and more opportunity to actually optimize that particular function, right. So, it is nothing but a mathematically you are giving more opportunity to optimize that function, and as a result the errors between what is expected and what is getting would also reduce. So, that is the reason the moment you give more and more examples, it cannot be repeated set of examples. So, the quality of the examples or the quality of the training data matters a lot, right. Once this is done, I mean once you develop a model which is expectedly correct, right, you cannot just start applying that model in the real world directly. You need to have something where you can evaluate the model. There has to be certain metrics, there has to be certain way in which you need to evaluate this model, how good this model is ultimately, right. So, we test the model performance. There are different metrics for different kind of the algorithms and different kind of learning types, right. So, we test this model performance using unseen data, right. Obviously, I cannot give the same data which I have given for training. It would be just kind of recall the things from the database. So, I have to ensure that how this model behaves, how correctly this model is behave in terms of predicting, in terms of classification when an unseen data, when a new data is given. So, that is what a test data is, right. So, there can be different evaluation metrics, as I told you. With the time you would be able to learn that what are the different evaluation metrics for different the problem types. For example, if we are talking about the classification problem, like for example, we are given the task of finding whether given mail is spam or not. So, the metrics would be like accuracy, precision, recall, F1 score. With the time you would be able to learn that, right. For example, the problem type is regression, like where you would just like to predict the house prices. So, there the metrics would differ, like there can be root mean square, there can be R square score, right. So, those metrics would differ. Similarly, when we talk about the medical risk prediction, so F1 score would be more useful. So, ultimately what we are trying to say is that there would be different metrics, there would be evaluation scheme that needs to be that should be able to ensure that the algorithm, how good that algorithm is and whether that algorithm can be used for the real data or not, right. So, we ensure model works well on the real data ultimately and does not overfit. Overfit means that it is just like you do not just memorize it, right. So, memorization means suppose you have learned something and you are given with the same thing that you have learned and then it would be recall kind of thing. So, it is not memorizing, it is more of a learning that we are talking about, right, from the data. Then once you have evaluated a model, right, it comes the deployment phase. So, deploying the model, the correct model using in the real world, right. So, the trained model is integrated into a real product or service, right. You might integrate it as into application, into some mobile application for example, right. So, once that model is developed and evaluated, you integrate that model in the real world where you actually now start giving the real data, the real unlabeled data, and then it is expected to produce correct results. So, mind you, when we are talking about correct results, unlike exact algorithms, it would eventually make some mistakes still, but the expected behavior is that it should behave approximately as correct as possible. So, the accuracy should be as close to 100%, but you cannot expect that algorithm would always or the machine learning algorithms would always behave exact nature in terms of it would always give the exact outputs. So, majorly it would depend upon the kind of input or the data it would have been given for prediction, right, whether that data, whether it has learned those aspects of the data during the training or not, it would depend majorly on that part, right. So, if we talk about machine learning entire life cycle, so I mean there can be real world deployment examples, like for example you may have Gmail filters coming emails like you have indicated in the email box itself, like for example Uber where predicts the right fare based on the distances, like Netflix recommends the movies, right. So, you are integrating that into integrate these models or actually those functions into in the real world where it is to be used. So, now the model is helping the users with the real time predictions, and that is what exactly is the entire purpose behind the scenes, right. And obviously, you cannot end over here, like once you have developed something, once you have integrated into models or put into the real world, you need to monitor and maintain also, right. So, this is something which obviously goes on, right. It is it's something which is a continuous activity. So, monitoring and maintenance, you need to keep improving it. So, keep improving means like you doesn't have to rewrite the algorithms, it doesn't have to rewrite those rules, you do not rewrite those algorithms, rather you improve those algorithms by giving more newer examples, more data which was not it was not trained on before, right. So those new examples, those data would eventually be given and it would be retrained, and eventually the algorithm would learn to make use of those new data, right. And those new data and those new data would help us to learn the rules which was not learned before, and that is how it actually goes on, and that is what we say that we need to monitor and maintain, right. And it is something which is a continuous process, right. So what we have performed as a steps, we track the performance on daily or the weekly basis. It can be retained with the new data, it can be like improve the model if the accuracy drops, right. So machine learning is in a way I would say a continuous learning activity, okay. We can talk about the types of machine learning. So when we talk about machine learning types, so majorly there are three ways or three types of learning. One is supervised learning, one is your unsupervised learning, other is your the reinforcement learning. So we'll quickly go through all these three kind of learnings. So when we talk about supervised learning, so it talks about where the machine learns from the labeled data. That means you have been given the answers as well. You have been given a question, you have been given answer. So it is just like making a student to learn for the exam. So he would be given the questions as well as with the answer. So what he is trying to do is learn, sees the question and also the answers and trying to see whether he is learning correctly or not. So with the time it would learn, right. So we know the correct answers already. So learning actually is nothing but the mapping from the input to the output, right. So the function would get developed, right. And different people with the same set of input and output would learn differently, and therefore that function f would also get developed differently. So that is what we say that these are not exact algorithms, right. So the function would depend majorly on how many examples, how many instances of input you have given and how many instances you have taken output, right, and how many examples you have taken. So whether you have been able to learn properly or not, and once that learning is done, that function is developed, you are expected to work on the new examples. You might be given an unseen input, and if you have learned correctly, you are expected to produce the correct output, right. Similarly, like the training data provided to the machine learning works as a supervisor that teaches the machines to predict the correct output, right. That is what exactly. So and this applies the same concept, like for example a student learns in the supervision of a teacher, right. So I mean there can be number of examples or applications of classification, like from Google image classification, the face recognition system, like filters where spam filters, where document tagging can be one of the examples, fraud detection. So many examples of classifications, right. And there can be many algorithms that actually that puts into the category of supervised machine learning algorithms. Linear regression is one, logistic regression is one, nearest neighbor problem is one, naive Bayes is one, supervised support vector machine is decision trees, random forest, neural networks. So a good number of categories of the algorithm that are put into this particular category, right. So supervised learning, actually there are two specific problems into it. One is classification and one is regression. So there is little difference between the two, although both of them are under the category of supervised learning. So when we talk about classification, so we are required to classify a given input into specific groups which are already known. Like for example, I want to classify whether the mail is spam or not. So those classes are defined. May want to classify given input into multiple classes, like for example the grades A, B, C, D, E. So those grades are known. So based on your input data, which might have multiple features, I want to classify my inputs into those known classes that would be called as target classes, right. So if this is happening, it is the classification problem. The name itself is relevant enough. Regression is another form where instead of known classes or target classes, here based on your data, based on the features that you have been given, you actually forecast or actually you are predicting a value, a real value. Like for example, you have to predict the sales based on your previous data. So here that Prediction would be a value. What would be my sales next year based on my 5 years data? So here you are predicting a value, not a class. So here the output is a real value. So that's the basic difference between the regression and classification. For example, based on the number of inputs, you want to predict the house price, right? So there can be number of examples. Now you can eventually think about for a given problems, whether it belongs to a classification problem and whether it belongs to regression problems, and it needs, both of the problem needs different treatment. For classification there would be different set of algorithms, for regression there would be a different thought process and different mechanisms to solve it, and the evaluation metrics would also be different, right. Now when we talk about unsupervised learning, the thought process is that we are not given any labels. I does not have any answer, I does not know the answer to a given input, right. It is just like, suppose you have been given certain inputs, but you does not have labeled them, you does not have what are the labels associated with them, right. But still I want to learn from the data, still I would like to learn, I have to use that data, right. For example, suppose you have been given number of pictures, right, for example. So suppose you have been given the pictures of digits from 0 to 9, multiple pictures of 1, multiple pictures of 0, different digits, but you have not been tagged, you have not labeled those pictures. So it does not know the image having 1 is actually 1, image having 2 is actually 2. So you have not mentioned that, but still you want to learn from that data. So this is definitely a little difficult task as compared to the supervised learning task. But over here how we can learn is, we can learn through identifying the patterns or the similarity between the data, right, and that similarity between the data or the statistical similarity between the data or some statistical significance I have to find out from the data in a way so that I can group the similar items into one group and dissimilar items into another group, right. So it would be kind of clustering. So I am formulating the groups, I am putting the similar items based on some similarity, statistical similarity, the same items. For example, if we are talking about if a mail is spam or not, if these are the two classes which I doesn't know about. So if I have been given multiple mails and some examples of them are spam mail and other would be non-spam mail. So all the mails which are spam would have some similarity statistically, that kind of data, right. There would be some kind of statistical kind of similarity among those kind of mails. So eventually with the algorithm I should be able to formulate those clusters or those groups, and then once that groups are formed, I have to define the name of that group, I have to define what exactly that group means, and then definition of that group needs to be defined by the person, like this group sees this and this similarity, therefore it might have this meaning or this actually resulting in this kind of activity, right. It similar to, like for example, you might have the different kind of news articles, then you have to tag them into different groups. News articles may be a sports item, it may be entertainment item, etc., right. So there are number of examples where we may not be given labels, right. So there is no teacher, there is no supervision, to be very frank. The machine figures out the hidden patterns on their own, and as I told you, this becomes a little difficult task as compared to the previous task, right. There can be multiple unsupervised learning algorithms, that can be k-means, hierarchical clustering, DB scan, mean shift, in fact Burke. So these are basic clustering algorithms. There can be other category of algorithms which are studied under unsupervised learning called association rule mining, which a priori algorithm, FB growth, the multiple algorithms. There can be a category of algorithms called dimensional reduction algorithms like PCA. So there are good category of algorithms that belongs to unsupervised learning, and there, if you see in your real world, there are many a place or many times you are not given labeled data. You would not always be given the rules, or they would not be given the examples where you know what is the answer is, but still the human mind is good at solving such kind of problems, and that is what unsupervised learning is all about, right. There can be good number of applications as well, like customer segmentation, right, where you want to cluster the group of your customers based on say for example, it can be budget shoppers, it can be a frequent shopper, it can be a luxury buyer. So again, similarly it can be fraud detection, anomaly detection, right, you find the unusual behavior, right. Similarly, it can be news articles that I gave you an example, it can be the product recommendation where we normally call association rule mining, right. Now, let us also talk about something called reinforcement learning, which is another kind of learning, which is a type of machine learning where a program or a computer learns by doing, right. So, it tries some actions, it gets rewards or punishments, it is a hit and trial kind of thing, and learns to take the best action over the time. And most of the places we do the same thing when you play a game, right. So, with the time you learn what is the best move to make, you make a lot of mistakes, you make, so it is more of trial and learn, and you learns with the, you start taking the best path and the best actions, so that you increase the probability, increase your ability to solve that problem in a better way. So, that is what reinforcement is all about, right. So, like it learns from your experience, obviously, it learns on a trial and error basis, and feedback is the most important aspect. So, feedback should be instant from the environment. It can be, that feedback can be used in the kind of reward and penalty. So, whenever you make a wrong move, you get a penalty. When you make a right move, you do a reward, you getting reward. You just assume an analogy where a dog needs to be trained. For example, dog does not understand a human language, obviously. So, the best way of would be making him train would be a reinforcement learning. So, whenever whatever we want to make a dog learn, so if it makes the right, it goes in the right direction, you give him some kind of reward, right. So, with the time, and if it does not go in the right direction or does not do what is expected, you give him kind of penalty, maybe not giving some kind of reward, maybe. So, with the time the dog would start applying his thought process and would start moving into the direction where he is getting reward, and that is what a hit and trial kind of mechanism evolves around it. So, just like human learns cycling, right, that is again an example, you do a lot of mistakes. So, there is no defined rule for it, right. You have a good balance of reward, continue, fall down, right, penalty, to try better next time. So, these are some of examples where the reinforcement learning is useful. So, what exactly, I mean, it requires an agent, that is the learner. It can be, for example, the robot or software, it can be the learner, right, or it can be human, right. Environment is important where the agent would interact with. It can be the game, it can be the road, it can be market, anything, right. It has the, and another important thing is action. So, what is the agent does, what exactly it is expecting to do, right. Then the reward, which is again very important, the score which would be given for good or bad actions. So, the goal would be obviously to maximize the rewards over the time, right. So, the good number of examples of reinforcement learning which is being applied and is well known, self-driving cars, where using actions could be turn, accelerate, braking, right, reward could be stay safe, follow the rules, right. It can be the penalty can be like collision, over speeding kind of thing, and the car learns to better drive over the time. So, similar in game playing is a perfect example which is based on hit and trial kind of thought process, right. Robots, the way robots work in factories, the way it is trained, right. So, again reinforcement learning algorithms, there are quite a many value based methods, they can be policy based methods, they can be actor critic methods. So, there are a good number of algorithms which are which comes under the category, they can be model based methods as well. So, this was all about the introduction part. I hope you would be able to learn from what has been discussed today. So, thank you everyone for this session.